This is video on Chapter 8, Section 4. Please disregard that it says Section 2, it's really Section 4. We'll be looking at how to find the distance between 2 points on a coordinate grid. And the 2 points that we're going to use as an example in the beginning is the distance between 3, 2 and 8, 6, or this line segment right here. And the principle that we're going to use is that we can go straight over from 3, 2 and straight down from 8, 6 and create a right triangle, and then use a comparison of 8, 6 and 3, 2 to figure out that the distance from going over 3 and going over 8 is 5 units, and going from 6 up to 2 up is 4 units. And then we could use the Pythagorean theorem, apply the Pythagorean theorem to figure out what the distance. So just kind of isolating that segment, we would see 3, 2, 8, 6. We would have to figure out how far it is if we go straight over. So we already counted that on the grid, and then straight down. But let's use a subtraction to figure that out. We know that this point was over 3, and this point was over 8. So the distance that it went was 8 minus 3. So this would be 5. And from this point here to here, which this was over 8 up 6, so this was up 6. This point was up 2, so the difference here would be 6 minus 2. So again, we get the 5, and then we get 6 minus 2 being 4. Now we'll look at how we apply that with the. So we had points 3, 2 and 8, 6. Actually, this is the actual distance formula that I'm going to show you. The distance formula says that the distance between 2 points, which are identified with coordinates, and our coordinates are 3, 2, 8, 6, would be x2, which we'll call this x2 right here, 8. This is just a subscript, and x1, that doesn't mean to a power, it just means we've got 2 x coordinates, one of them is 8 and one of them is 3, and we have to use the letters or the subscripts to identify which one we're referring to. Then we square that. Then we find the difference between the 2 y coordinates, and we square that. Then we'll add them up and take the square root. So it looks kind of tricky, but it's really pretty simple when you plug the numbers in. D is going to equal, D is going to equal, we'll just go ahead and put them in here, 8 minus 3, so I'm taking the 2 x coordinates. Then I have to square it. Then I take the 2 y coordinates, 6 and 2, and subtract them. Extend this over a bit and square them. So I've just taken these, I'm just using the formula and putting in for x2, I'm putting in 8, for x1 putting in 3, for y2 which is here, put in 6, y1 in this position I put in a 2. Then I do the arithmetic and I get D is equal to the square root of 8 minus, we're going to do a couple of steps here. 8 minus 3 is 5, and 5 to the second power is 25. 6 minus 2 is 4, and 4 to the second power is 16. And when I add 25 and 16, I get 41. So D equals the square root of 41, which it's approximately, it's between 6 and 7. So I'm just going to guess 6.4, but you could use a calculator or a square root table to figure that out more precisely. So let's look at another example, and this one's going to have some negative numbers in it. It's going to make it a bit more interesting and perhaps challenging. So the coordinates that we're going to use now are negative 7, 2 and negative 2, 10. Let's get this over a little bit, make some more space to work with here. So using the formula, the distance will equal the square root of, it doesn't matter which, I was thinking negative 7 to be x2, negative 7 minus negative 2. I'm going to right now make that plus positive squared, plus 2, it's this 2, minus 10 squared. And I can make this, it's going to be tricky to squeeze it in here, plus negative 10. So, doing the arithmetic, 7 negatives and 2 positives makes 5 negatives. Negative 5 to the second power. And 2 plus negative 10 is negative 8. It's negative 8 to the second power. And if you're thinking ahead, you can see it doesn't really matter whether the numbers in here are positive or negative, because when you square them, it's always going to be positive. The result will be positive. So doing some more simplifying, negative 5 times negative 5 is 25. Negative 8 times negative 8 is 64. And 25 and 64 makes 89. So the distance would be the square root of 89, which is between 9 and 10, a lot closer to 9. I'm saying approximately 9.1. I'm just estimating that. Maybe 9.2 would be closer. But that's the idea. So, see, this would be approximately 9.1 units. And that's how we use the distance formula.